guys, Assalamualaikum, very good morning. So for today's lesson, we are going to talk about the last part of kinematics, which is acceleration. So before we have learned two parts which are displacement and velocity. So for today's lesson, we are going to talk about acceleration. So before we go further on for the acceleration, let's look at these two cases. Okay, so from these cases we have velocity time graph, in which the difference are, in case 1, velocity time graph is a linear equation. However, in case 2, we have quadratic equation. So when we have these two different cases, let's look in detail what does this graph means. Okay, so for this first case, the linear graph, so as you can see, if we interpret this graph, so at this T1 we have this velocity, and at the second we have this velocity. So we can say that, okay, first of all, what is acceleration? Okay, acceleration is the rate of change of velocity with respect to time. So you have learned about acceleration in physics. So what does physics say about acceleration? Acceleration is the change in velocity with respect to time, in which you get this formula, v2 minus v1 over t2 minus t1. So what does acceleration means in mathematics? So basically, when we talk about the change of velocity with respect to time, we are talking about the differentiation. Okay, we differentiate velocity with respect to time. So what does acceleration means in terms of mathematics? Acceleration is dv dt. Okay, acceleration is dv dt. How can you find acceleration? When you are given velocity function, you need to differentiate velocity function in order to get acceleration function. So A is dv dt. So as we look at this linear graph, okay, so we know that graph linear, what is the properties in linear graph? We know that in any 2 points on the same line, we will have the same gradient. So when we talk about differentiation, what does gradient stands for? Gradient stands for dy dx. Okay, in this case, velocity time, gradient stands for dv dt. Again, when we talk about dv dt, what are we talking about? We are talking about acceleration. So the rate of change of velocity, in this case, case 1, the rate of change of velocity with respect to time at any moment will be the same. Why? Because all of the points at the same straight line will have the same gradient. So it has the same gradient. So we can say that dv dt or dv dt as considered as acceleration, acceleration will remain to a constant value. Let's say a is equals to 7, a is equals to -2. Okay, understand? So in this case, a will be equals to constant value, and then the acceleration of the particle will remain the same throughout the motion. Of course, from here to any second at this t of n, the dv dt or the acceleration will remain the same. Okay, so that's what we call, in this case, the particle will have uniform acceleration. Okay, so this is in case 1. However, when we look at case 2 we have we have quadratic equation, right? Quadratic graph, right? So for any points at a curve, on a curve, we will have a different gradient. We've learned this in differentiation. At any point on the curve, it will contribute to a different gradient. So again, when we talk about gradient for velocity time graph, we are talking about dv dt, in which dv dt will represent acceleration. So at this point, the acceleration will become different with this point. with this point. However, when we look at from 0 to a, the interval for time 0 to a, the gradient will be positive. Okay, the dv dt will be positive. Okay, in which we will say a will be greater than 0. Our acceleration will be positive. However, when t equals to a, okay, when t equals to a, dv dt equals to 0. Why? Because our gradient tangent or our tangent line is parallel to x-axis, in which we contribute gradient equals to 0. So at this part, at this time, when t equals to a, dv dt equals to 0. So we say that our acceleration will become 0. However, for this point, our tangent line is decreasing. So we said that the gradient must be less than 0. So dv dt will be less than 0, which means that our acceleration will be negative. So for this case, okay, this is what will happen in this case. So for the time within 0 to a, the velocity increases with time. So in which we say that the acceleration must be positive. So at that instantaneous time, the instantaneous acceleration at any point within this frame of time will be positive. Okay, within the interval will be positive. Okay, however, when we talk about when time equals to a, in which the graph is maximum or minimum, so we said that the velocity is equals to 0. Why? Because we said that the gradient tangent equals to 0, in which the gradient tangent is represented by dv dt. So the zero acceleration, okay, you need to remember that zero acceleration doesn't mean that the velocity is 0. When a equals to 0, that doesn't mean that v is equals to 0. However, you need to know that when a equals to 0, the velocity will become either maximum or minimum. Okay, velocity will be either maximum or minimum when a is equals to 0. Okay, let's look at this time frame. So when when the time frame is between a to b, the velocity decreases. Okay, the velocity decreases with time. So we said that dv dt less than 0, which means that acceleration is negative. So the instantaneous acceleration at any point within the interval is negative. So can you understand? So another thing, okay, we need to know the concept. Okay, so we've learned that from s, okay, we have s, displacement, we have velocity, and now we have acceleration. So how can we find velocity when we have displacement function? So we said that in order for us to find v, we need to differentiate s when you are given s. Okay, how about when we are given velocity, how can we find a? So we said that in order for us to find a, we need to differentiate v. Let us look backward. Okay, if we are given acceleration function, how can we find velocity? So this is the inverse process. Okay, from a, how can we find velocity? So v is equals to integration of a with respect to time. The same goes to s. When we are given v, how can we find s? So s is equals to integration of v with respect to time. Okay, so how about we are given s and then we need to find a. So basically, from s to becoming a, we need to see s to v, first derivative, v to a, first derivative. When s becoming A, so we are talking about the second derivative. Okay, the same goes to from A to S. Okay, so from A to S, so S, okay, this is single integration. So from from A becoming S, we are talking about double integration from A with respect to time. Okay, so this is the concept of acceleration. Remember this part and this part, and this is the crucial thing you need to understand this. Okay, so we are going to look at example in the next video.